Hello, I'm Maria Nadestad, and I am a bioinformatics software engineer, but some of the tools that I use a lot in my work are Pandas and Altair. I use these to make all kinds of different visual dashboards and plots and doing data analysis. And last week I felt like checking out my own transaction data from Mint, so I exported it, did a bunch of data analysis to try to figure out different restaurants and grocery stores and things like that, and how my spending has changed, especially over the course of the COVID pandemic. So in this video, I'm going to show you how to do that same analysis with your own data. I'm just going to use simulated credit card data here, but you can take this notebook from, I'll link it in the description box below, and I'll also put it on my GitHub. And so then you can go and take it for yourself and run through the same analysis. And otherwise you can just follow along and see, how I do this data analysis, and hopefully you'll walk away with some tips for using Pandas and Altair for analyzing all sorts of data or your own transaction data from Mint. So let's get started. So the first thing I'm going to do is just show you where to get the transaction data in Mint. So inside Mint, you want to go to the tab at the top that says Transactions, and then you just have to scroll down to the bottom of this table and hit that little button right here, this little link that says Export All Transactions. In the Colab notebook, you would then go over here to, this says Files, it looks like a little folder icon, and you say Upload to Session Storage, and once you click that, you can select the files that you want to load and load them in. So once you have that, I'm just going to import Pandas and Altair. Those are our main libraries that we're going to work with. And here I'm going to simulate some credit card data so that we have the data frame with that data in it, and I'll just show you what it looks like otherwise. So these are the instructions that I just showed you how to do, but this lets you list the data that's there. If I do that, I can kind of see that I have just sample data, but if you load your own files, they'll be next to this. And then you can look at the top of them, and you can read them into different data frames. Here we use read CSV, which works great because these are CSV files. And if you have more than one credit card like this, you'll have more than one CSV file. Load them into data frames individually, and then you can use pandas.concat and just do like a list of the different data frames here. That gets combined into one data frame, and then we're ready to roll. So we don't need to do that because we have simulated data. So I already have this data frame called df, and I'll actually just show you what that looks like. So again, this is simulated data that we're using here. We can see that we have a credit card payment, and it says label credit. We have some debits. This is exactly what the data looks like coming out of Mint as well. You have a date, you have the description. The original description is usually just another variation on the description, but it might be that you've edited this in Mint if you have been kind of curating your data a bit more. There's amounts, which is how much was spent at each place, or this is a credit card payment, so it's how much you paid. And we have categories, which are going to be really helpful. So this is what our data looks like. So now we get to the point where we can make our first chart in Altair. So here we do alt.chart, we pass it the data frame, which actually includes information about what type each of the columns are, so it'll automatically interpret that. That's really important. It makes it really nice to combine the Pandas data frames with Altair. And this is saying what kind of plot we want. We want our data points to be points, so they're going to be little circles. And then encode is what you always use to tell Altair which part of the chart you want to come from which column in your data. And you can do additional interesting things here that I'll show you later, but this is saying that on the x-axis I want the date, and on the y-axis I want the amount. So I run this, and just to let you know, when I run things, I usually use Command Enter because I'm on a Mac. I think it's probably Control Enter if you're on Windows, but if not, you can always just click this play button here as well to run the cell. And we have our first chart. Yay! Now, one thing that you probably immediately notice here is that all of the dates are just like listed out, and they're not even sorted correctly by date. They seem to be sorted kind of alphabetically so that the years kind of get mixed together because the years are last. What we actually want is to have the x-axis show up as real dates. Now, what I'm guessing happened here is that the dates we have in our data frame are not getting interpreted as dates correctly, because Altair can normally figure that out for us. So what we have to do is tell Pandas that this particular column of the data frame needs to be a date-time data type. So this is how you do that. You have PD, that's Pandas again, to date time, and you give it the column. And then we assign that back to the date itself. And if you want to inspect this first, so the way that you could kind of try to figure out how this problem is happening in the first place is you have this, and data type is object, and then you'd probably Google how to get Pandas to recognize a column as a date, and you'd find a result a lot like this. And then you try this, and first we have data type object, but when I run this, we say it's a date time, and you can see the formatting also changed. So before we have slashes and the year is last, but now the year is first, and we have dashes here. So interesting. This probably means that it figured out how to parse it correctly, and it looks pretty reasonable to us. So now we're going to run this, which assigns the result of the same thing we did back here into the date. So we're replacing the date with the date formatted as the date time data type. And now we have these. So one thing you can do real quick is just check that the date probably, looks the same as it did up here. So we have 2019 7/25. And this is 2019 7/25. Good. So this looks correct. And now we can do the same plot again. And when I run the exact same plot we did before, but the data frame has changed underneath, we now get the x-axis showing up, recognizing that our date column is in fact date data types, and so it's very nice. So, okay. The next thing I want to try is, hovering over some of these points and figuring out what they are. Why do we have all these larger transactions? What are they? This is simulated data, so it's a little ridiculous. I don't know that anybody is spending this much money on such random things, but let's see what they are spending so much money on. What I did here is I added tooltip. So aside from this, all of this code is the same. But I just added tooltip, and you can actually list multiple things. So check this out. When I hover over one of these points, I get the description, the category, and the transaction type, because that's what I listed here. I can also add other things like date, for instance, run it again, and now when I hover, I also get to see the date. So this is really cool. This is one of my favorite things about Altair. It just makes it so easy to work with and to kind of inspect my data and to dig in more detail to figure out what's going on. So let's hover over a few things. Oh, I see some credit card payments here. Yeah, a lot of them are credit card payments. Of course, I simulated this, so they're all over the place, but for you, they would probably be like once a month or something. So let's see if we can filter those out, because I'm not really interested in the credit card payments when I'm analyzing how much money I spent on things. You really just want to see the transactions. So we know that the transaction type for all of the expenses are debit, and for the credit card payments, they are credit. So I'm going to filter out anything that's credit by saying transaction type equals debit. And this is the first time we're using this thing. This is kind of a good practice for working in Pandas, although there's other ways you can do the same thing. You basically say, I want the parts of the data frame where the row fulfills this condition, and I want all of the columns. You could also say I want a specific column by listing the name of the columns here, but this is something that we're going to do a lot in this notebook, where we just filter based on some kind of condition on the row. And when you do this part individually, this gives you a series of booleans where you have false for the very first one. If we look again at our actual data frame, the first part right here was a credit card payment. So that checks out. And when we do transaction type equals debit, we get false for the first one, true for the rest. So then when we run this, we're saying, I want my df variable data frame to be replaced with the data frame, but only the rows where it's debit. And so when I run this, we now have filtered out many of the rows of the data frame, and we can run this again. And here I actually also added color equals category, which is pretty cool. But you can also see that most of our larger, what looked like transactions at first, have disappeared because they were all credit card payments, and so now it's a lot simpler. We can also rerun the one up here, and you can watch the dots disappear. Ta-da! Yep, so now we only have some of the larger transactions left. So that's pretty useful. And yeah, so the other thing that we're changing in this chart is that we're coloring by category. This is another one of my favorite things. This is so easy to do in Altair, and it just comes out looking really cool. So you can see these two are, someone bought like a auto and transport, something, maybe parts for their car. This is some business services with Olivia Pope and Associates. This is so funny. So here, this is really cool. We have all these interesting categories. And okay, so one thing that I had to do for my own data, so I'll show you how to do that as well, is to filter by dates. So in my case, I wanted to see all the transactions after 2019 because something changed about my credit cards, like the data wasn't reliable before 2019 really, and so I wanted to just filter to any dates after that. So this gets you all the dates starting on January 1st, 2019. So this is another way to filter. And this is just how you would do it for dates. I had to look this up, of course, just Googled how to filter on dates and pandas, and this is kind of the result that I got. But yeah, Stack Overflow is great for this. I usually Google for it and then, pick the best answer I can find on Stack Overflow once I get there. So that's just a little tip. And so now that we have that, let's just see, we'll just plot again. It's so easy to make plots. So now we're starting on 2019. Sweet. So the next thing I wanted to do is I want to see more of these transactions that are at a much lower level because I have a few of these larger transactions, but what I'm really interested in are trends around spending on food because there are so many of those transactions. This is cool, but I kind of get all the information that I need to see about these just by looking at them. So now I'm kind of done, seeing all the large transactions, and I want to zoom in on the smaller ones. So let's just do a filter here for any transactions below $200. And again, like we're doing the same kind of filtering, so it's very powerful. You can do a lot with it. And let's plot it again. And now we see a lot more of these transactions spreading out, so this is really cool. This is very interesting. We have some grocery runs. Somebody's been going to taverns, 3 broomsticks, etc. That's fun. So when this is your own data, it's a lot more interesting. But this kind of gives you an idea of what you might be able to see. So very cool. So right now all we can really see is all of the transactions, but I'd really like to get an idea of how these are adding up in any given month. So let's start by saying, I want to see the sum for each category first, just which category are we spending the most money on. And it looks like that is restaurants. So I should mention here that we've changed from mark point to mark bar. This is especially nice because now we're summing the amounts. So we could also do this with points, but it just looks a little bit more confusing. It makes it look as if you're plotting one transaction, when in fact you actually, are seeing kind of a sum. So I think the bar is a better way to show sums. So that's just like a basic visualization tip. And here the restaurant spending is clearly very high. There's also some spending on groceries, a bit on shopping, a lot on alcohol and bars as well. And this is like over our 2-year period. Let's not judge the amounts too much, they're all simulated, but when you look at your own data, it'll be more meaningful. So this is cool. And one thing I wanted to do here was combine some of the food spending. So this happened in my own data as well. Some of the food spending gets put into fast food versus food and dining versus alcohol and bars, but basically all of them is just you're eating out. So I wanted to combine all of those into just, along with restaurants, into a category just called restaurants. And you might be going to something that's technically a pharmacy, but you're really buying groceries there, or, other way around. So sometimes you might want to combine those two categories as well. This is all going to depend on what you want to see in your own data, but this is just what I'm showing here, so you kind of get an idea of how you could do it too. So what we're doing here is we're going to take the category, which is what we're plotting on the x-axis here, and I want to create a different column in the data, which is going to be called group. You call it super category or something like that. But here it's group, and we're going to base that group column on the category column, but just summarize it basically. So this is a way that you can do a lot more flexible things with pandas. So we basically say I have this particular column and I want to apply this function to it. And now inside this function, you can do whatever you want. All you're taking in is one category, which is just a string. We can even, add the type annotation here to say this should be a string. And the category comes in and you see whether it matches one of these. And if it does, you return restaurants. If it matches one of these two categories, then you return groceries, and otherwise you call it other. And that goes into our new column called group. There's been this warning a bit lately. I initially did get rid of it, but it seems to come back once I rerun things a few times. This is a warning that's trying to tell you that you might be doing something slightly dangerous on slices of your data that it isn't sure whether you wanted the new data frame to be a copy of the old one, so that it's completely separate, or if you want it to just be a view into the old data frame, which means that if you were to change something in the new data frame, do you want that thing to also change in the old data frame that you are slicing from, or do you want it to be completely separate? I'll show you an example later of when we take a slice on purpose and take a copy of it on purpose. But that's just something, I just want to explain what this warning is so that you're not thrown off by it. So here we go. Here we don't actually care. So the important thing to mention about the warning right now is we don't care because we're assigning it back into the original data frame anyway and overwriting it. So we don't actually have to worry whether we have two different data frames that are out of sync because we're only working with a single data frame and we're just replacing it each time. Okay, so with that out of the way, we can now see that we have this column called group. And it's got groceries, restaurants, and other stuff. Okay, so let's check whether our new group column is useful and whether it's mapping correctly to the categories. So this is a little chart that I'm going to make just to visualize whether the transformation I'm doing has worked well. This is kind of a little sanity check. So I basically plot the old categories on the x-axis and the new groups on the y-axis. And that way I can see that the different things that I wanted to map to restaurants are always mapping to restaurants. And I don't have like multiple categories, or I don't have the same category going into multiple groups, because that would be really confusing. So little sanity check, and let's move on. Oh, one thing I guess to mention here is that the x-axis and the y-axis are now both categorical, and that's totally fine. Categorical meaning like non-numeric, but instead being made up of some kinds of categories or something. Okay, so now let's use our new group column to color the data points. So we're going to make a plot a lot like what we had before, but now instead of coloring by all of the categories, we're just coloring by groups. And I think this was especially helpful in my own data because I ended up having like 100 different categories and you couldn't even see them all on the side. And so you have so many colors that they start repeating, and that's just like not very useful to look at. So this gives you kind of a condensed view of it, and that way you can see some trends better and so on. Instead of doing mark point, we can also do mark line. If I do the exact same thing, you're just connecting, or Altair is going to connect all of the points together as long as they are the same color. And if you were to add additional characteristics here, you can actually add all sorts of interesting things. But it's going to connect everything in this case that is the same color, because that's the only separation that we have between these different data points. And that might appear really obvious, but when you start adding more things, it can get a little bit, more complicated to see like, oh, when is it going to separate them into different lines? So I don't think a line chart is perfect for this. I'd really like to see some trends, but it's just connecting all of the individual transactions, so it looks completely nonsensical. So let's instead take our mark line chart and add a little bit of binning to it. So this is where we get a little fancier, like what I was saying at the beginning, how X and Y can also be something a little bit more than just the column names. So here we're saying that instead of just having the date, I want just the year and the month of the date. And I'll show you what some of these things look like if I remove them. But first I'll just talk through what this is and then show you the chart. So the y-axis, we're going to have the sum of the amount. And let me run this. Okay, so on the x-axis, you now see the month and the year, and there's only one data point for each month. And then you can kind of see the trends and so on. So it's a lot easier to see trends here than it was to see it up here, where we're showing every single transaction as its own data point. And these are summing the amounts for these bins, and Altair just figures that out for you, which is so fantastic. This is so helpful. So let's see, what else can we do here? So I wanted to show you what it looks like if I don't use year month here, and I just show the dates on their own. So now we have all the dates broken out. And this actually lets you see what the O does as well. Because if I have the O, that means it's ordinal, which means that it has an order, but I also want to see them individually. When I remove that, we keep the order, but we don't break the dates out individually anymore. They don't all have their own tick mark. They get put into a numeric axis like this. And they spread out according to the date. So they're actually spaced not evenly here, but according to their actual dates. Whereas here, each one, regardless of how close or far apart they are, they will always come out just being right next to each other. Like they're not going to be spaced based on the dates. So you won't be able to see clustering, for instance. So anyway, let's bring this back to year month, and I'll show you some of the other transformations you can do on dates. Because here we're showing the month and the year. One thing that you might often be thinking is like, oh, I just want to see like each month. What does that look like? now you just have the months. But it's actually summing January of every year together, which is not what we wanted here. We actually wanted to see it in like real chronological order. So that's why we add year a month. But this type of chart could be really helpful if you are looking to analyze seasonal data and you do in fact want to compress it based on that scale. We could also do year alone, which is just going to give us a data point for each year. Since we filtered to just 2019 and later, this is a really boring chart now. But this is how we ended up with this. And again, if I just take this out, then you're going to compress it, but you can't see each individual month listed out anymore. So that's why we added the O here to break out the months into their own data point so that they're more visible and it's easier for us to look up, oh, what happened in June or August or something. For this one, if I take away sum, what does that do? This will now have each individual data point connected to each other. It's a little easier to see what happens if I show them as individual points. So you can kind of play with the chart in different ways to debug what's happening in your chart. We have all the same points that we had in some of the charts earlier, but they're now compressed into, like, all the dates in January are not broken out next to each other, they're right on top of each other, because they're all just being binned into January. So this is kind of saying, I don't actually want to know the full date, I just want the year and the month of that date. So when I make this back into a line chart, it's just going to connect all of these. So you'll have just like straight lines because all these points are getting connected to each other, and then there'll be one jump into the next month. So not super helpful. We want this to be summed by the month so that we only have one. And I guess I'll just show you this with the points too, so that you can kind of see how we go from having a lot of points on top of each other to having one of each type of point, which now represents the sum. And so then when we make that back into a line chart, we get these nice trends. So this is how you can kind of play with it. Now, what if we make this chart into a bar chart instead? So we have the line chart here, and we're taking the exact same settings, but we're making it into a bar chart instead. So this becomes a stacked bar chart by default, and here I've added some tooltips as well. And so you can also do the sum of the amount in the tooltip. So useful. It would really be annoying to have to set all of this up myself every time. So it's really nice that these things are built into Altair already for us. So yeah, it's the stacked bar chart. And you get the same numbers that you did here, but see how when it's a stacked bar chart, the trends are going to be looking different. The main part is that here in the line chart, I can't really see the categories adding up very well. I can't see what the sum is. But here, that's the most salient part of the chart, is how high up is the sum of the 3 different categories for each month. So you can kind of see the trend in the sum, not just in the individual ones. But you can also see pretty clearly how much of the total amount is made up of restaurants versus groceries, for instance. So bar charts are really helpful for something like this. They're good for communicating sums and, to show data that you've binned. And they're really good in stacked bar charts for showing how much of a total amount is made up of the different sub parts of it. So that's another, core visualization thing to think about when you're visualizing data. And let's see what I wanted to show here. Oh yeah, this is what I was showing before. So this, just gives you other ways to look at the same thing. What's this one? Ooh, okay, in this one I'm showing how to break these out into separate charts. So before we just colored by the group, but I can also say that I want to break the data out into different rows by group. And this is super cool, because now I basically get 3 charts built into one, and they share the x-axis and so on, and there's a lot of nice things about this. The other way to go is to make this column by group, and so then you get this, and they're gonna share the same y-axis now, regardless of how high up they all are. That means these, if plotted alone, this chart would not have its y-axis go all the way up here. It's being set by the maximum, which is in groceries, not in other or restaurants. But they're all adapting to each other and sharing the y-axis. So that's pretty cool. So this gives you just, another view into the data, which can be really useful when you have a lot of different columns in your data and you want to plot as many of them as possible to get an idea of the combined trends between all your different variables. So that's another way to go. This was useful in my own data because I could see some of the trends individually between groceries and restaurants, especially, to see whether some of the transactions were higher or lower over time, and so on. So breaking them out can give you a little bit more of a detailed view. So now we're gonna look into restaurants very specifically. I'll actually show you a little bit how to do something in Colab notebooks that's nice here. So we can do a large title and say breaking out restaurants on their own. And this looks like a nice title. And if I want to make it kind of a lower level title, then I can put these 2. I can also do all sorts of like italicizing and things like that. So you can, use this to style your Colab notebooks. So that's just a quick tip on Colab notebooks if you're not familiar with them. And so we're breaking out restaurants on their own. Here, I'm going to do the exact same kind of filter we did before with df.lock and say where group is equal to restaurants. So this is using our new group column that we created before. And I want to break that out. So this is where we do a copy of it, because I'm not just assigning this into data frame. I want a new data frame called restaurants. And I want to be able to make changes in restaurants, like adding a new column, which we're going to do in a minute, that I don't want them to affect the original data frame, df. So that's why I use .copy. So this goes to the warning I showed before. This is us doing this on purpose so that we know what we're doing and making sure that we're not, changing the original without meaning to. So we have this new thing called restaurants, and it only has restaurants in it. Cool. This is 526 rows. You can always look at this to see whether your filtering is doing anything. And sometimes it isn't, so it's good to pay attention. So here we're gonna plot just restaurants. So we always used to have df here in all the previous examples, but now our new data frame is just restaurants. And we're gonna do a point for each one. We wanna plot date on the x-axis, amount on the y-axis like we keep doing. And I wanna color by the description. So that's something we haven't done before. And then I wanna set the title equal to just restaurants. And of course, we always want to have a nice tooltip. I'm very generous with tooltips because they let me see a lot of good information. So now we're actually plotting all of the restaurants. And one thing to notice here is, you might even have seen this earlier if you were doing your own data, but notice that the blue repeats. So the first one is blue, and then this one is blue again, and then there's another one that's blue again. The color scheme repeats. There are only so many colors in the color scheme, and so that's gonna be kind of a limitation, and we don't generally like to plot these as all different colors if the color pattern is just gonna repeat like this, because then you look at something blue and it could be 2 completely different things. These all happen to be Moe's Tavern, which is cute. Oh, Artisan Fern Cuisine. Another restaurants. another restaurant that's also blue. So we don't want that. We want to kind of try to limit the number of categories here, or the number of descriptions, which are the restaurants. Actually, I'll also show you one little thing here. If I do alt.color and set it to description, this will do nothing, but it's a little wrapper that lets me set additional things. And let me see, I can set a title, it says, and I want this to be restaurant, because that's what the description actually is in the context of this chart. So this lets me change the title of the legend here so that instead of it being just description, it's restaurant. So that's another little trick. We often have to do fancy things like this in Altair, so this is a good one to know. This I used alt.color, but you can, for X it would be alt.x, for Y it would be alt.y, and so on. And so this gives you some nice flexibility to add titles and make things look cool, and there's all sorts of interesting things you can do, but just consult the Altair documentation. In this video, I'm really only showing you some tips and tricks, but if you have trouble with anything, you look it up in the documentation, okay? Because all of this is going to be documented very well with nice examples and so on. I'm just showing something very specific here. So looking at this, we talked about how there are too many different restaurants listed so that we use up the whole color scheme more than once, which isn't good. So what I want to do to fix this is to pull out just the restaurants that we go to the most. So here, let's figure out which restaurants we are going to the most often and just give those a color, and then give every other restaurant just the color other, so that we can give them all like the label other and make them all the same color, so that we can easily just tell apart the ones, get some kind of information out of this instead of just a mess of different colors. So what I'm going to do is try to plot which restaurants you go to the most often. And I'll show you the plot so you have an idea of what this is doing. So all these plots I experiment a little bit, I Google a little bit sometimes to figure out things like this. So here, if I don't sort, you're just saying x equals description. I added alt.x, which, like I showed before, does nothing at first until you add additional things to it. But what it would do if I don't sort is look like this. And I just wanted to sort it so it's easier for me to kind of see. So I'm basically saying I want to sort the x-axis, all the items and labels on the x-axis, I want to sort them by y. And if I just sort by y, then they go ascending, but I wanted them to be descending, because when I did this for myself, I had so many restaurants that they kept going off to the side. And so that's not very useful. I want to be able to see them right front and center here, or right up at the left. So the one that the simulated data goes to most often is Bubba Gump Shrimp Company. Cool, and the Krusty Krab and Good Burger and Time to Eat and so on. So that's very cute. Here for the y-axis, we're plotting the count. So just like sum of amount, this is a calculated amount based on the binning. So it's basically saying, like, for each thing that you might plot on y, just combine them and count them. Instead of the count, we could also do the sum. So count refers to how many times they've gone to the restaurant, but sum of amount means how much money have you spent in total on that restaurant. And so we have these different ways of plotting it. But I think they seem to be giving mostly the same results in terms of which are the top restaurants. But in fact, we can actually see that. We can try to plot them against each other. So if you're curious, you could say plot on the x-axis the count, and on the y-axis the sum of the amount. And let's color by description, which is just the restaurant's name, and run that. So now this should tell us how correlated are the total sum versus the count of how many times they've been there. And so you should see something like this most of the time, with dots falling kind of below the straight line representing restaurants that are cheaper, and dots above the line representing restaurants that are more expensive on average. So the real point that we wanted to do here, of course, was to limit the number of things that we're showing in the legend and limit the number of colors that are being used for multiple things. So what we can do is create a list of the top restaurants and limit them here. This is a little bit similar to what we did when we were creating the group variable, but here we have to determine what the categories, what kind of the super groups are that we want to create on the fly. So we're going to do it based on the restaurants themselves. So instead of me figuring out which are the top ones, I could kind of read off the titles for all of these, but that's not automated enough for my taste. There's got to be a better way. And this is the better way that we find. So we take the restaurants, take their descriptions, this is the name of the restaurants that we have here. We can do value counts, and I'll actually show you what this does on its own. So this gives you the exact same numbers that we were plotting here, but just in a nice little neat list. And then I wanted to just grab the first 9 of them. So that's index 0 through 9, not including 9 itself, but because we're counting 0, it's 9 total. So this gives us the top 9 restaurants, and I'll show you in a second how I could tell that I wanted 9 of them. But now that we have that, we do index. So this gives us just the names of the restaurants, and then we convert it to a list. And so now it's a list of restaurants, and we save that into top restaurants. So I can delete this again. I usually like to save just the things that actually do something, or things that I want to keep in mind for later. So here I'm still showing the top restaurants so you can actually see them, and then we're going to use them next to not filter the data, but to create a new column that's interesting in our data. So we take the description and we apply a function again. And this function is a lot like what we did when we created the group column, but now we're saying if description is in top restaurants. So we generated that list dynamically, and then we see whether the description is in it. If it is, keep it. That's great. If it's one of these, I want to know which one it is. But if it isn't, I just want to return other, because that way it's like pretty easy. And I'll actually capitalize that. And let's run it. And we can see our new restaurants. We have some of them that are less common, that are named other, and some that get to keep their name. So very cool. Now let's plot it again. And this time we're going to color by our new column called restaurant, which also means I don't have to retitle it. So that's another tip. You can always rename the columns if you keep having to set the titles. And in here, you can now see that we have all these different places. And we have other, which is in yellow. And that is excellent. So you can see we don't repeat any colors. I counted these and figured out how many unique colors we actually have. That's how I determined that I wanted to have exactly 9 of them. And so this lets you kind of limit it down so that you can better see which restaurants you're going to the most often without getting multiple colors representing, without getting one color to represent multiple things, because that's kind of messy. Okay, so the next part of the analysis is basically doing the exact same thing we did for restaurants, but doing it with groceries. I think this is mostly interesting when you're doing it on your own data, but I just wanted to have the code here for you so that you can actually see what's going on, and so you can easily run it with your own data. For groceries, we're again doing the same thing of taking a copy of the data. And note that our restaurant column that we created before when we were working with restaurants has not affected this original data frame, the column isn't there, and that's because we did copy before when we were working with the restaurants. That kept our existing DF data frame safe. And so now we can plot, the same kind of plot we've been doing a million times, but just do it with groceries alone. And we can find the top grocery stores. Here we don't need to do that, but maybe in your data, you've been going to many different grocery stores. And so you want to be able to, plot them out and kind of condense that data a little bit. In our case, we also had some grocery stores that the names had kind of changed over time. Like they'd added a comma before Inc. or something in the name of the grocery store, but it wasn't, it's not a different grocery store. So you can do some kind of custom cleaning here as well. For instance, if they might be spelling Acme in two different ways, what you could say is if Acme in description, just return Acme. And there you go. And you could also say upper. So they could, for instance, be saying, Acme in lowercase, but also Acme in uppercase, and so on. So if you do description upper, and I'll show you what that looks like a little bit. See, how many of these do we have? We don't have so many. I'm actually gonna print description.upper in here so you can just see what it looks like real quick. And so now we're uppercasing it, and that lets you check whether this is inside of this string, and then you just return this. And that's helpful because then you don't have to check whether it matches, like if you don't have to check whether it matches Acme or Acme or Acme, like spelled in all different ways or capitalized in different ways, basically. And this also lets you see, like, maybe sometimes it's Acme Corporation, maybe sometimes it's just Acme, and so on. So you can kind of check for these things without listing out every possibility. So Acme in this means like if Acme is a substring. So this would fit this if statement, for instance. And so when I run this, our Acme Corporation comes out to be just Acme. So you can do some custom cleaning like this instead. And I'll make this else if just so it's easy to read, but of course these are returning, so it's the same thing anyway. So this is just showing you some like custom data cleaning that you can do, which might be necessary, and you might want to do that for some of the restaurants as well. This can be like a really common thing. Depends on how perfectionistic you want to be about your own grocery store analysis. And then we're gonna do the plot again, and now see it's just Acme. And here we're just plotting the grocery stores. And again, we created a new column for grocery store, which let us do some custom things here as well. So that is it for this analysis. I hope you enjoyed it and you found it useful, and that you're now excited to go pull your own data on transactions from Mint and load it into this notebook. If you want to find this notebook, I will put a link in the description box below. With that, I hope you enjoyed this, and leave a comment and let me know if you found this helpful, and like, subscribe and all that jazz, whatever. Okay, thanks, bye!